All right, today we do section 4.4.1, where we begin to actually deal with some proofs. We're going to begin with a relatively simple proof called a two-column proof. With two-column proofs, you're going to draw two columns. You're going to put what you know in the left column, and how you know it in the right. Before we actually do a two-column proof, we're going to run through a little bit of what proofs are. So proofs are just kind of explaining why you know what you know. So for this problem, before we actually write a proof, we're going to just explain in words. We're going to talk about how we know that angle F and angle V are going to be equal, given this information here. So if I gave you this picture and this information, how can we know that F and V are the same instead of different? So one way we'd go about doing it is actually just kind of exploring it and saying, okay, well, I know Fi and Vi are equal, so I can mark them equal. Those are equal. I know IR and IE are equal, so like, okay, well, I can mark them equal. And when I look at that, I see a couple of triangles and I remember like, oh, these angles, they're definitely equal too. They're equal because they're vertical angles. And now I can look at those triangles and say, I see a side, an angle, and a side, an angle, and a side. Those two triangles are congruent by side, angle, side. And if they are congruent, all of their parts are congruent as well. So this angle F here is going to be the same as that angle V there. They're going to be equal because the triangles are congruent, right? So we're going to do that in a proof. Before we do it, there is a shortcut. That last explanation we said when we said, since we know the triangles are congruent, that must mean their angles are congruent because all the parts of congruent triangles are congruent. That's given us commonly written as a shortcut called CPCTC. It stands for corresponding parts of congruent triangles are congruent. In other words, if you know two triangles are congruent, so if I know those two triangles are congruent, you know all their parts are congruent. You know they have congruent sides, those ones are congruent, those ones are congruent, you know they have congruent angles. It just means if you know triangles are congruent, then that means all of their parts are congruent to each other as well. It can be written as a shortcut CPCTC, so you don't have to write out that whole explanation every time. Okay, this would be something I would definitely write down in your notes. Maybe pause the video to do that right now. All right, now we're ready for our first proof. Here will be our first proof. I would recommend you write it down and follow along. Also, there's a little note. Don't forget to add a picture to the proof. The proof without a picture doesn't make a whole lot of sense. So this part of the proof is actually pretty important to have. So we're given some information. We're given a picture. We're given some given information, and we're going to prove that angle F and angle V are the same. This is the same proof we just talked through, right? It's the same proof we did right up there, but now we're actually going to write it out as a proof. So with a two-column proof, you write what you know on the left side and why you know it on the right. One thing I know is I know Fi is congruent to Vi. And then I can mark it in the picture, Fi and Vi. But then the big thing with a proof is a proof you need to state why you know it. It's not enough to just say, oh yeah, they're totally congruent. The biggest part of a proof is giving reasons. So we have reasons to believe you're right. So in this case, how do I know they're equal? Well, that was given to be true. So the reason I know that is it was given. All right. The next thing I'm going to state is IR is congruent to IE. That length and that length are equal. How did I know that's true? Well, that was also given. All right. Now you might recall before that I had mentioned the triangles were congruent by side, angle, side. I can't list that in this proof yet because so far I've only listed a side and another side. I haven't listed the angle that's congruent, right? So I need to list that angle. That was these angles here. So that's the next thing I'm going to write in my proof, that those angles were congruent. All right, so this angle and that angle congruent. I'm just going to put numbers by them, 1 and 2, because that's a handy way to just call the shortcut. Then I can see angle 1 and angle 2, and I can say angle 1 is equal to angle 2. But again, I can't just say they're equal without a reason. Why do we know they're equal? Because those two angles were vertical angles. And we know vertical angles are always, always, always equal. Vertical angles, again, are angles that happen when you get that, when two lines cross. All right, now I've listed a side, I've listed an angle, I've listed a side. And yeah, it's not in the same order here, but that's okay. I've got it, I can see in the picture that, oops. I can see in the picture that I'm gonna have a side and then an angle and a side. It's definitely the side angle side shortcut. So I can say that the triangles are congruent by side angle side, making sure of course that I list the triangles in the right order. So I'm gonna call the triangle on the left triangle FIR. And if I say this one's FIR, the one on the right I'm gonna have to call VIE. So triangle FIR is congruent to triangle VIE. How did we know that was true? Well, by our side angle side shortcut. All right, we're finally there. I was asked to prove that angle F is equal to angle V. I now can state that. I can say angle F is equal to angle V. How do I know that these angles are equal? Well, because the triangles were equal, right? If the triangles are congruent, so are all of their parts. I could write that out. I could say, because the triangles are congruent, so are all of their parts. But that gets to be a really long reason. And so that's where this handy shortcut came in. Corresponding parts of congruent triangles are congruent. CP, that's the shortcut for saying, hey, if the triangles are congruent, so are all of their parts. CP. There's the proof. All right, that CP shortcut, we are going to be using that a lot. If you like, I've got a little way to remember it. When I was in high school, I had a math teacher. And we did need to memorize CP, and I would recommend you memorize it. But the way he did it was kind of fun. He talked about in Battleship, the game of Battleship, the PT boat is the smallest boat. It stands for patrol boat, I believe. So that's what he told me. So he said the way he remembered CP is he thought of a PT boat lost in the seas. Get it? All right. Okay. Let's try another proof. Here's my 2 columns. Let's actually start writing out a proof. All right, so I'm going to be asked to prove that angle A and angle O are the same. Whenever you have a proof, the handy thing is to start with your proof is to always just start with your givens. Those are things I know, they were given to be true. So that's what I always start with. I know AR is congruent to RO. And I know AW is congruent to OW. Why do I know that? They were given to be true. So like that's an easy. So all proofs you can at least get the very start by just writing the givens. After you write the givens, it's a really good idea to mark those on the picture because then it'll give you an idea of where else you need to go with the proof. So let's see here. Here's AR and RO, those are the same. AW, OW, those are the same. I'm probably going to have to state those triangles are congruent, so I'm going to look for a way to say it. And I say, oh, wait, I see it. I can do it by side, side, side. But so far, I've only listed 2 sides, right? I've listed that side and that side. I need a third side. Well, the third side is that one right there. They both share a side. So it seems kind of silly, but I do have to write that down. So I'm going to say RW is congruent to RW, right? This side is equal to itself. They share that third side. The reason we can say that, that's kind of a silly one, so I'm okay with whatever. There's a fancy word for it, but if you just want to write same segment, That's just fine. You can write, I know it's equal to itself because duh, RW and RW are the same segment. Go ahead and write same segment if you like. If you wanted to sound fancy and all mathematical, the fancy word for that property is called the reflexive property. The reflexive property in math is just the property that says anything is equal to itself, like 5 is equal to 5, 4 is equal to 4, RW is equal to RW, right? I'm okay with any of those reasons, just as long as you state some kind of reason you know it was true. You can write same segment, you can be all mathematical and write the reflexive property, whatever you like. All right, now that we listed it though, now I can see, oh, I've listed all 3 sides of those triangles are congruent. So now I can say the triangles are congruent by side, side, side. So that's what I'm going to state next. Triangle, let's see, I'm going to name this one on the left ARW is congruent to triangle. Let's see, if I said ARW, that would be the same as ORW, right? Going along the 1 line and then the 3 line. So ARW is congruent to ORW. Why did I know those triangles were congruent? Well, from the side, side, side shortcut. All right. Don't stop there. Remember what we're trying to prove. The whole point of this proof was to prove angle A and angle O were the same. Now that I know the triangles are congruent, all of their parts are congruent, including A and O. So the last thing I'm going to say is that proof. Like the thing you're trying to prove is always going to be the last step. So I'm going to say angle A is equal to angle O. How did I know that? Well, I knew it because the triangles were congruent, so all of their parts are congruent. That had the fancy shortcut, CPC TC. There is my proof. All right, we're gonna work through one more and then you're gonna try some on your own. All right, one last one. I would recommend, it wouldn't be a bad idea to pause the video and try this one on your own to see how well you get it. You can look at the previous examples for something to help. But I'm gonna start this now. All right, so I'm going to admit trying to prove AB and BC are the same. As always, before I do that, I'm just going to list the things I already know. I know my givens. So I know AD is congruent to DC. And I know angle ADB is congruent to angle CDB. How did I know those? Because they were given to me. Those were given to be true. Once you write it on the proof, again, it's really, really helpful to mark those things on your picture. So AD and DC, I'm going to mark right here, AD, DC. Angle ADB and CBD, oops, CDB, I wrote that wrong. There we go. Those angles are here and here, right? A to D to B, C to D to B, those are the angles. Those are given to be the same, so I'm going to mark them the same. And then I'm going to look at that picture and see if there's a way I can state the left triangle and the right triangle are congruent. Well, I see they both got a side. I see they both got an angle. And they share a third side. So that's the third thing I'm going to write. I'm going to write that BD is congruent to BD. To remember why we can say that. All right, if you said same segment, you're right, same segment works great. If you said reflexive property, you're being all fancy mathematical. That is also right. I'm gonna write reflexive property because I like being fancy and mathematical. But if you wrote same segment, that's exactly fine. All right, now I've got these two triangles are congruent by side, angle, side, so I better write that. Triangle ADB is congruent to triangle CDB by side, angle, side, right? I listed up here a pair of sides, then a pair of angles, then a pair of sides. That's side, angle, side. And again, the important part of that is if I know the two triangles are congruent, then all of their corresponding parts are congruent, including those ones, right? That side of the left triangle and that side of the right triangle, they match up they're going to have to be congruent because the triangles are congruent. So that's always the last thing I write in my proof, is what I'm trying to prove. AB has to be equal to BC. I knew that because the triangles were congruent. Remember that fancy shortcut? C, PC, TC. Corresponding parts of congruent triangles are congruent. That's it. In class today, we're going to work through a couple together. We'll probably work through the homework together. If this seems kind of strange to you, I would highly, highly recommend working through it with the class. Otherwise, I will see you in a bit. Bye-bye.